Good morning, champs. Let's solve a full Rankine cycle step by step. We are given a steam power plant with four components: pump, boiler, turbine, and condenser. Our goal is to calculate pump work, turbine work, heat input, heat rejection, net work, and efficiency. We start from the general steady flow energy balance. For each component, we use 0 equals heat plus work plus mass flow times enthalpy in minus mass flow times enthalpy out. We neglect kinetic and potential energy changes. First, the pump. The pump is approximately adiabatic, so heat is 0. From the energy balance, we get pump work equals mass flow times the difference H1 minus H4. So we can write H1 equals H4 plus WP. Now, for liquids, we approximate the pump work using WP equals V times delta P. This works because the specific volume of a liquid is nearly constant. Next, the boiler. There is no shaft work, so W equals 0. From the energy balance, Q in equals mass flow times H2 minus H1. In specific form, Q in equals H2 minus H1. This is the heat added in the boiler. Now, the turbine. The turbine is also approximately adiabatic, so heat is 0. From the energy balance, Wt equals mass flow times H2 minus H3. In specific form, Wt equals H2 minus H3. Now we determine H3. We are given the quality X3. For a saturated mixture, H3 equals HF plus X3 times HFG. This comes from the definition of quality, where X describes how much of the fluid is vapor. Next, the condenser. There is no shaft work, so W equals 0. From the energy balance, Q out equals mass flow times H3 minus H4. In specific form, Q out equals H3 minus H4. At state 4, the fluid is just completely liquefied. That means X4 equals 0, so H4 equals HF. Finally, the net work and efficiency. The net work is W net equals Wt minus Wp. And the thermal efficiency is eta equals W net divided by Q in. This definition tells us how much of the heat input is converted into useful work. Now, let's describe the process in the PV diagram. From 4 to 1, the pump creates an almost vertical line upward. From 1 to 2, the boiler creates a horizontal line to the right. From 2 to 3, the turbine creates a curved line downward and to the right. This is the adiabatic expansion, and the curve is steeper because no heat enters. From 3 to 4, the condenser creates a horizontal line to the left at low pressure. Each component creates a characteristic shape, and the turbine clearly shows the adiabatic curve.